The major difference between a one-step function machine and a two-step function machine is that in a one-step function machine, there is only one operation happening at the process stage. While in a two-step function machine, in the process stage, there are usually two operations going on. Let me give you an example. In a one-step function machine, for example, we learned that in the process stage, which is also called the operation stage, there is usually just one function happening here. Let's say we could just be multiplying by 3. Given an example, let's say we have an example of 2 as our input. Since the operation is by 3, we just multiply by 3 and it ends up giving us an answer 6. This answer is called the output. This was what we did in the one-step function machine. But in a two-step function machine, it's a bit different. It is different because instead of just multiplying by 3, you might see operations of this nature. The input is 2, and then you get to a process where you have times 3. And instead of yielding the output, you have another process involved, which is, let's give an example, plus 2, before you can now generate your output. This is a good example of a two-step function machine. So 2 times 3 is going to give you 6. 6 add 2 gives you the output 8. Now, when you are given a two-step function machine problem to solve, a lot of the time, the output is either missing or the input is missing. Sometimes also you find out that the process is missing. In that case, how do you find out exactly what transpired? Exactly what happened in between? Let me give you a trick. Let's see if you can find out exactly what happened. Take for instance, you have the number 1 that goes through a process and then goes through another process and ends up yielding the answer 5. What would have happened? Be thinking, let's see. Now I am going to use the same process to show more numbers. Maybe that will help you to be able to find out exactly what operation happened when you are trying to find it out. Alright, let's think again. We have the number 2, and the number 2 goes through a process, and it goes further to go through another process, and it ends up yielding the answer 9. By this time you would be thinking, what happened? Now if you can also find that, let me give you what happens in the third case. In the third case, it goes through the first process and it goes as far as happening the next process and ends up giving us the answer 13. Have you noticed anything changing? Well, if you are noticing, use it to find the final one. So if we had the number 11, what would be the answer? So your work this time is to find out what happened in the process stage and at the same time to fill in the number missing here. Now pause the video for a moment and find out what actually happened. Let's see if you can actually find it out. Did you find the operations that actually existed in these two stages? And were you able to fill in the missing number for input of 11? Well, if you found it out, well done. Let's compare our answers together. First, notice something. Somebody might say, okay, this could be 1 times 2, which is 2, and I will add 3 to it to give me 5. But if we go by that, 2 times 2 will give me 4. If I add 3 to it, I won't succeed to get the answer 9. Remember, every number on the left must have similar operations to give you the numbers on the right. In that case, we have to pause and think. The simple process that existed here is a process of 1 multiplied by 4 and then add 1. Let's see if it works for all the numbers. 1 multiplied by 4 will give you 4. Add 1 to 4, you get 5. That works. 2 multiplied by 4 gives you 8. Add 1 to 8, you get 9. It works also. 3 multiplied by 4 gives you 12. Add 1 to it, you get 13. So, to get the missing number for the number 11, 11 multiplied by 4 is 44. Add the number 1 to 44, you get 45. If you got this answer exactly the way it is on this board, then you are correct. Now, before us are a few questions that we need to solve. First, we have the first function machine given to us up here. where we have to add 5 to the input and multiply whatever we get by 2 to get the output. To begin, we have 3. So 3 add 5 gives us 8. 8 times 2 will give us 16. This is done. As easy as that. Now, this is the reverse work we need to do here. Remember I told you in the first video when you watched about one-step function machine that when you are given the output, for you to go back to the input, all you need to do is to reverse the mathematical operations. Here we have times and here we have addition. For us to reverse, the times has to change to division while the addition changes to subtraction. That is the only way we can easily come back successfully to our input value. So to do that, all I will need to do is first divide 64 by 2. That gives me 32. And 32, subtract 5 from it, that's going to give me 27. This is the number we are looking for the input. To check whether we are correct, you can use 27 to go direct and see if that gives you 64. Check it out. 27 add 5 gives you 32. 32 multiplied by 2 gives you 64. So we are correct by this number. The next thing we are going to check out is the next function. We also have 2 questions to solve here. One is to fill in the input box. One is to fill in the output box, while the next is to fill in the input box. But notice something. The operation has 2 steps, which is multiply by 10 and divide by 5. Since I know that 10 is a multiple of 5, I can easily break it down by first dividing 10 with 5. If I divide 10 with 5, that gives me the number 2. So instead of multiplying by 10 and dividing by 5, I just have to simply multiply by 2. Because 10 divided by 5 gives me 2. So I just go straight. 12 multiplied by 2 gives me the number 24. That is your answer. Otherwise, if you need to be sure to cross-check whether you were right with this calculation I just did, you can check it using the 2 steps. Now let's confirm using the 2 steps. 12 times 10 gives me 120. 120 divided by 5 is going to give me the number 24. It works. Okay, let's work out 200. Since I know that multiplying by 2 is the simplest rule to use here, all I will need to do is to take the reverse of multiply. That gives me divide. So 200 divided by 2 gives me 100. Deal is done. Otherwise, you can go slowly by going by the principles given, the operations given in between. Just reverse them. 200 multiplied by 5 gives you 1000. 1000 divided by 10 gives you 100. The same thing. It works. Alright, we have a little kind of challenge down here to do, but not much. It's something you can do. The first one requires us to multiply our input by 2 and subtract 3 from it. Our input here is x, an unknown number. This is a variable. So all we need to do is multiply x by 2. That's going to give you 2x. When you subtract 3 from 2x, since we don't know the value of x, so 2x minus 3 remains 2x minus 3. 2x minus 3. We can't go beyond that since we don't know what value x stands for. But in the next case, we have the output. We need to find the input. There are still 2 stages involved. Take a look at the stages. Minus 5, add 3. You know from your negative number operation that minus 5 add 3 will give you the number negative 2. So instead of subtracting 5 and adding 3, I can simply use the number negative 2 to work here. That is minus 2. So since I'm coming back from y and I have negative 2 here, I have to change it to positive, the reverse operation. Remember that. So y add 2. Since I don't know the value of y add 2 remains y add 2. That is my input. This is how it works. Nothing bigger than this. With this understanding, you can also create tables and solve other kinds of problems, just like we did when we dealt with one-step function machine. In case you haven't seen that video, try to make sure to see the video on one-step function machine, as that will help you get a better grip of the introduction to algebra. Now we'll be ending the video here. I need you to look forward to watching the next video, which is the video on how to form expressions and some terminologies that we use in algebra. Thanks a lot for watching.